Hello everyone, welcome to second semester of Geometry Standards. Today's our first day of notes. Okay, so we're going to work on 5.7 notes this week, so please go ahead and pull those up on your iPad, put them into Notability, and then split your screen. Okay, go ahead and pause so that you have the time to do that. As we go ahead, we're going to work on Pythagorean proofs today and tomorrow. Okay, so the first one today is just a proof. Remember, Pythagorean theorem is our a squared plus b squared equals c squared. And this applies only when we have right triangles. Okay. So we did work with this last semester, but now I want to go through a proof with you. Okay. So to start off, our Pythagorean theorem states that on a right triangle with a and b as legs, and C as the hypotenuse, okay. Then a squared plus b squared equals c squared. Okay, so here's our formula. Okay, we've seen it a million times, and we're going to see it a million more. Okay, now this applies in our picture. Okay, so remember, a leg is what is touching the 90-degree angle. So this only applies when we have this box or it says it's a 90-degree angle. Okay. So I always like to identify my hypotenuse first, and it's wherever my box is pointing. Okay, so it's pointing this way. So my C, or this long side, is going to be my hypotenuse. Okay. And then my legs are what's touching the box. So the box touches here, so that has to be a leg, and it touches on this side, so that has to be a leg. Okay. Now, A and B could be switched, but they do have to be the sides touching the 90-degree angle. Okay. My hypotenuse is the one across from it. Okay, so let's go ahead and get started. Okay. So our first proof, we are going to show that a squared plus b squared equals c squared. Okay. So in order to do this one, we need to remember some formulas. Okay. So our first one is the formula for the area of a square. Okay. Now if you remember an area of a square, we are going to take our base and we're going to multiply it by my height. Okay. And we're also going to be talking about the area of a triangle. And that is the same thing, except we're going to divide it by 2, or take 1/2 times the base times the height. Okay, so we are going to be talking about those as we go through this proof. Okay, so we need to show the area of the entire square. So we're going to be using this picture off to the side. So first, let's do the area of the entire square. So I'm going to do this in red. So if I have my sides, okay, and I want everything that's in between it. So let's highlight the red. Okay. So on one side, my base, I always like to put it at the bottom. I don't know why. Okay. I'm looking at the base. So I know that it's B length and it's A length. If I want to combine something, that means I need to add them together. Okay. I want it to get bigger. So because I like alphabetical, I am going to put this as A plus B. Okay, so that's going to be my base. And then I'm going to look at my height. Okay. Well, again, looking at that whole section of my height, okay, it has an A section and it has a B section. I want to combine them to get a big section, so I'm going to add. So my height is again going to be A plus B. And we know that those are the same, so if they are connected for a square, they do need to be the same. Okay. So the area of the entire square, so remember the entire red triangle that I highlighted the middle of, the base was A plus B, and my height was also A plus B. Okay. Now if I have two binomials, we need to distribute. So this is the double whoop whoop, this is distribution, this is the box method. Whatever works the best for you, that is how we're going to multiply this. Okay. So I'm going to start with my first term, A, and I'm going to multiply it by my first term over here. So A times A will give me A to the second power. Now I stay with that first term A, and I do it to the second term. So I'm going to multiply A times B. That will give me A, B. Pretty simple. Now I get to move on to my second term. I'm looking at B, and I do the same thing. The first B times A, I'm going to flip that order just so it's alphabetical. So that's going to be A, B. And then that B times the other term, which is also B. That will get, B times B will give me B to the second power, or B squared. Okay, and we're going to combine our like terms. Okay, so this will give us A squared. Well, these two are the same. And remember, we don't multiply them, we're adding them. So there's two of them, so it's going to be 2AB. And then I have that B squared at the end. So when it's asking me for the area of the entire square, it's going to be A squared plus 2AB plus B squared. Okay. Now I need to find the area of one triangle. Okay, so I'm going to do this one in green, and I'm going to use this triangle down here. Okay, I'm going to outline it. It is a right triangle because the corners of my square are always 90 degrees. Okay. So I know to find the area of a triangle, I need to do 1/2 times the base times the height. So if I have 1/2, I'm going to multiply it by my base. In this case, my base was B, because it's on the bottom. So my base was B, and my height, remember these are my two legs of a right triangle, is A, so I'm going to multiply it by A. So 1/2 B times A. So if they're asking me for the area of one triangle, it's 1/2 B times A. Now I want all four triangles. So if you see there's four right triangles here, and they're all exactly the same. They have a B and an A as their legs. Okay, so all of those areas will be 1/2 base times height. So to do that, we're going to combine them all. So if there's four of them, I can multiply by 4. So I already have the 1/2 right here. Okay, it's already in that formula for me. So I'm just going to take that B and that A and fill in that top part of the fraction. Okay, and now we get to do a little bit of math. We are going to take that 4 divided by 2, and that will give me 2. Okay, so 4 divided by 2 is 2, and then BA. I did that division. Okay. So if they're asking me for the total area of all 4 triangles, it's 2BA or 2AB. Remember, in multiplication, we can switch the order. Okay. And now it's asking us to do the area of a middle square. Well, if it's a square, we're back to the base times height. Okay, so I'm going to do blue, I guess. I'll do red for this one. So one side, my base was C. So I do C times my height. Well, that was C again. Okay. And that would give me my entire inner square. Okay. Well, I know that C times C is going to be C squared. So the area of the middle square is C squared. Okay. Now, how can we find the area of the middle square only in terms of A and B? Okay, so my middle square is c squared, but I want it to use a's and b's. So what I'm going to do is I'm going to erase my picture real quick. Okay. Now looking at this, I am back to my original square. So I started with this whole thing. Okay, so that's the area of the entire square. Okay, so the entire area. Okay, and now I want to take away the full area of the 4 triangles. So take away is minus, so I'm going to take away my triangles. Okay, so I'm going to erase them. I'm going to erase that one. I'm going to erase my top one. Erase this one. Oops, went a little too far on that one. And then this one. So all I'm left with is that inner square. I took away the triangles, and now I'm left with that yellow square. Okay, so that's where I'm getting this formula. That will leave me with that. So the area of my entire triangle, or entire square, was a squared plus 2ab plus b squared. Oops. And I'm going to subtract or take away the area of my 4 triangles. Well, I found out that that was 2ab, okay, and that needs to equal my middle square. Well, I know it was c squared, but remember we want to simplify this left side so that we can find what c squared equals in terms of a and b. So if I simplify my like terms, I have a positive 2ab and a negative 2ab. Well, now they're going away, okay, because they zero out. So now we're going to rewrite it. Therefore, we can say that I have an a squared, I have a b squared, and that's going to equal c squared. So I know that that yellow triangle can also be written as a squared plus b squared. Okay. Now if you want to check out more proofs similar to this, there's a great additional video for you guys to look at, and it talks you through some more, and it shows you some really cool pictures of it moving around. Tomorrow we're going to go through an example-based proof, and then we'll jump into our lessons about how we use Pythagorean theorem.